Modern bus stop shelter frames, the future of urban transit design. In the evolving world of civil engineering, bus stop shelter frames are more than just roadside structures. They are essential components of smart, sustainable cities. Today's shelters must meet high standards of safety, durability, and aesthetic appeal, while withstanding environmental forces and urban wear. Modern shelters typically consist of precast cantilevered frames that support a lightweight slab. These frames are spaced at 2.5 to 4 meters apart and are engineered to provide shelter from sun, rain, and wind. The cantilever design ensures maximum space utilization and minimum obstruction, allowing free movement beneath. Designing these shelters involves precision and structural detailing using M20 concrete and Fe415 steel to handle loads efficiently. The slab, usually 100 millimeters thick, is reinforced with main and distribution steel bars as per its standards. The frame consists of a tapered beam, column, and footing carefully calculated to resist bending moments, shear forces, and foundation uplift. Why cantilever? It's modern, efficient, and visually elegant. No rear support is needed, reducing material and site congestion. Civil engineers now use advanced modeling tools and real-time stress analysis to ensure structural integrity, reduce material waste, and fast-track construction timelines. A bus stop frame usually consists of a continuous slab supported on a number or frames of the type shown in here at a spacing of 2.50 meter to 4.00 meter centers. The supporting frames are usually precast. The following rules may be adopted in choosing the dimensions of the beam. Maximum thickness of the beam at the column end equals 215 millimeters to 220 millimeters per meter of projection. Minimum thickness of the beam at the end minimum to 300 millimeters. IIIB equals 0.6 OB2. IIIB IVT equals 300 millimeters. VT. Join us as we dive into a real-world design example of a cantilever bus stop shelter, breaking down each part slab, beam, column, and foundation with easy-to-follow calculations. Subscribe for more civil engineering tutorials and practical designs. Hello, welcome to Civil Engineering Edge. Today, we're designing a modern cantilever shed for a bus stop based on a real-world engineering example problem. Design a cantilever shed for a bus stop. The shed is 3.50 meters wide and 3 meter high above the ground level and shall consist of a 100 millimeters thick slab supported on frames to 0.50 meter centers. Use M20 concrete and Fe415 reinforced steel. Solution: the shed is 3.5 meters wide and 3 meters high. We'll use M20 concrete and Fe415 steel and support a 100 millimeters thick slab with frames at 2.5 meter spacing. Design of the slab: DL of 100 millimeters slab equals 25 by 100 equals 2,500 Newton. MA. Live load equals 1,500 Newton. MA. Total equals 4,000 Newton. MA. Consider a 1 meter wide strip of the slab. Maximum bending moment. M equals 400 by 253. 12 Newton meter equals 2,083.33 Newton meter. C equals 7 on DMA. T equals 230 Newton and millimeter 2. A equals 0.90 D and Q equals 0.913. Adopting 0.913 x PD2 equals 2083.33 x. Area of steel ast equals 2083.33 x 1000. 230 x 0.90 x 81 equals 111 millimeters 2. Space 111 equals 450 millimeters. Maximum permissible spacing equals 3D equals 3 by 81 equals 243 millimeters. Provide 8 millimeters dia bars at 200 millimeters CC. Ast equals 0.12x 1000 by 100 equals 120 millimeters. 2. Provides 6 millimeters dia 150 millimeters cc. Design of the beam. Consider 1 meter run of the beam. Load from the slab equals 4000 x 2.50 equals 10,000 newton a meter. Dead load of the beam 300 millimeters by 300 millimeters to 300 millimeters by 700 millimeters equals 0.30x 0.50x 25,000 equals 3,750 newton a meter. Total load equals 10,000 by 3,700 equals 84,218.75 newton a meter, equating the moment of resistance to the bending moment. 0.913x 300 dA equals 84,218.75 by 1,000 d equals 555 millimeters. Available effective depth equals 667 millimeters. So, area of steel, Ast equals 84,218, 230x 0.90x 667 equals 610 millimeters. 2. Provide for bars of 16 millimeters diameter. Maximum shear force, S equals 13,750 x 3.50 equals 48,125 newton. Nominal shear stress. EV equals SABD equals 48,001. 300 by 667 equals 0.24 in the May. Percentage of tensile steel provided equals for by 201. 300 by 667 x 100 equals 0.40%. For 0.40% steel, stress in concrete equals IC equals 0.7 Un per millimeter A. Provide nominal stirrups, say 2-legged 8 millimeters dia stirrups at 400 millimeters cc. Design of the column. Let us provide a column section of 300 millimeters by 700 millimeters. Total load on the column at the section PQ and the position of its linear action are now determined. See table below. Load due to magnitude of the load on distance from alpha, and moment about ANM from the slab. 4000 x 4.20 x 2.50 beam. 0.30 x 0.50 x 3.50 x 25,000 column. 0.30 x 0.70 x 4.30 x 25,000 42,000 13,125 22,575 to 0.10 0.70 plus 0.7 plus 0.6 0.7 plus 0.3 x 3.5 3 equals 0.70 plus 1.52 equals to 0.22. 0.35 88,200. 29,138. 7,901. Total 777001 to 5 to 39. Total load at the level PQ equals 77,000. Ast equals 1,016 millimeters. 2. Let us neutral axis be at a distance n from the compression edge. The distance of the neutral axis is given by 300x n 2 halves equals 13.33 x 10 16 650 n. NA plus 90.9n 58,687.55 equals 0. N equals 201.30 millimeters. Lever arm, alpha equals 650, 201.30, 3 equals 582.90 millimeters. Eccentricity equals 1610, 700 to 201.30 mm equals 1,111.30 millimeters. Let C be the compressive stress in concrete due to bending moment. 300x 200 1.30x C2x 582.90 equals 77,700x 1,111.30. So, C, compressive stress equals 4.91 Newton per millimeter 2. Stress in steel equals 13.33x 4.91, 650 to 201.30, 201.30, and a May equals 145.80 on per millimeter A. Direct stress in concrete in compression equals 77,700. 300 by 201.30 plus 13.33x 1016 and a May equals 1.05 un per millimeter 2. Resultant stress in concrete equals 4.91 plus 1.05 equals 5.96 and a May. Resultant stress in steel equals 145.8, O2 13.3 equals 0.70 x 4.20 equals to 0.9 for un. Provide a base width of 3.00 m. Let the maximum and minimum depths of the foundation be 600 millimeters and see table below. Load due to magnitude of the load and distance from alpha 1 moment about alpha 1 Newton meter. From the slab, beam, column, rectangle of concrete, 0.30x 0.70x 0.60x 25,000. Cantilever, 0.30x 2.30x 0.45x 25,000 4,200. 13,125, 22,575, 3,150, 7763 2.10, 2.22 0.35, 0.35 0.70 plus 0.60 plus 0.60, 0.60 plus 0.30. X 2.30 3 equals 0.70 plus 1.02 equals 1.7 to 88,200, 29,138 equals 1.58 to 1.50 equals 0.080 meter, but B6 equals 3/6 equals 0.50 meter. So extreme pressure intensity at the base equals 88,613. 1 plus 6x 0.08, 3 un per millimeter 2. So Pmax equals 114,212 un per millimeter A. And PMIN equals 82,700. 2x 0.30x 2.30 equals 70,400. This acts at a distance of equals 90,057 plus 2 by 114,212. 90,057, 114,000, x 2.30, 3m equals 1.20 meters from B1. Moment due to upward pressure equals 70,473 x 1.20 equals 84,567.60 Newton meters. Dead load of the cantilevering part equals 7,763 Newton. Moment due to dead load of the cantilever equals 7,763 by 1.02 equals 7,918.30 equals 76,649.30 Newton meters. Net bending moment BM equals 84,567.60 minus 7,918. So, D equals 529 millimeter. Overall depth required equals 529 plus 40 equals 569. Ast equals 76,649.30 x 1,000. 230x 0.90 x 560 equals 660 to millimeters 2. Provide for bars of 18 millimeters diameter. Check for shear. Maximum shear force SFS 704737766 to 710 on. Nominal shear stress equals EV equals S per BD equals 62,710 per 300 by 560 equals 0.37 MA. Percentage of tensile steel provided equals 1,016 per 300 by 660 x 100 equals 0.51%. For 0.51% steel P equals 0.30 and MA. Shear resistance of concrete SC equals PBD equals 0.30 x 300 by 560 equals 50,400 on. Net shear force SF to be resisted. This is very small. Provide to leg at 8 millimeters. Thigh stirrups at 200 millimeters CAC. That's how we design a cantilever shed for a modern bus stop. Please don't forget like, share, and subscribe for 2 Civil Engineering Edge for get more structural design tutorials. Stay till next video, please.
Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video. Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video. Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video. Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video.